In this problem, we're going to look at angular momentum. It says calculate the magnitude of the angular momentum. So we want to calculate the magnitude of L. And it's of a 0.5 kilogram rock, so 0.50 kilograms, spinning in circles at the end of a 0.75 meter string. So the radius of the circle is going to be 0.75 meters. Decimal in there. And then it says it has an angular velocity. That will be omega. And it is 4.0 radians per second. Now for this problem, what we know is that I, or L, equals the moment of inertia times omega. So notice the moment of inertia is not directly given, but since this is a rock, I'll draw a little picture here. This will be the rock spinning at the end of a string, which is 0.75 meters. This counts as a point mass going around a circle, right? So when this thing goes around a circle, what we get is the moment of inertia is just going to be mr squared for a point mass. So in this case, we can calculate I, our moment of inertia, which is going to be 0.50 kilograms times the radius, 0.75 meters, and that has to be squared. So when we calculate this out, we get 0.28 kilogram meters squared. So now I can go ahead and use I to calculate my angular momentum. Angular momentum, moment of inertia times omega. So this is just going to be the 0.28 kilogram meters squared times my angular velocity, that's given as 4.0 radians per second. And I then get my angular momentum equal to 1.1 kilogram meters squared per second. And that is the answer.